Now in this episode, continually we have to see how the Q table is forming. So what is the Q table? So the Q table includes columns and rows with lists of rewards for the best actions of each state in a specific environment. A Q table helps an agent understand what actions are likely to lead to positive outcomes in different situations. The table rows represent different situations the agent might encounter, and the columns represent the actions it can take. As the agent interacts with the environment and receives feedback in the form of rewards or penalties, the value in the Q table are updated to reflect what the model has learned. The purpose of reinforcement learning is to gradually improve the performance through the Q table to help and choose actions. With more feedback, the Q table becomes more accurate, so the agent can make better decisions and achieve the optimal results. So here we are having that is representation of that OR matrix. We are having this table, and then each rows and the columns is represented along with the weights. So from that the agent can easily able to understand where the agent has to move in order to obtain good rewards as well as to reach out the targets. So now we have to go with these parameters. So the matrix Q is the memory for that agent. It has to be learned that information from the experience that has been stored. The rows, what I said that earlier, they represent that present situations, the agent that has been encountered, and then the column denotes the possible actions leading to the next state. So the computation of that Q matrix seems to be Q of state comma action, that is the S comma A, equal to reward of the state comma action plus gamma, that should be multiplied by the maximization of Q of next state comma all actions. So this is the computation of the Q matrix. For each and every gamma value, we are having that set in range. So the purpose of that reinforcement learning is to gradually improve the performance of the Q learning, Q table, to help choose that appropriate actions. So when we have to go with that more feedback, the Q table becomes more accurate, so the agent can make that better decision on these things. So the Q table is directly related to the concept of the Q function. The Q function is the mathematical equations. So what we said that earlier, that looks at the current state of that environment and the action under consideration as inputs. So the function that that generates the outputs along with the expected future rewards for that action in the specific state. So the Q table allows the agent to look up the expected future reward for any given state action pair to move toward the optimized state. And next episode we are going to see about what is the Q learning algorithm and what are all the process, what should we have to do when we have to be comparing these states. That means if the gamma is less than 1, and then what will be the gamma that is the closer to 0, or what will be the gamma that is the closer to 1. So what should we do, that everything we are going to be see on that next episode. So along with that steps involved in that circuit learning.